Say what?
Could you report people that ain't here?
I try to. I almost forgot. My math class, I'm doing pretty good. I'm still starting on forensics. That's a lot of stuff I keep forgetting. I've done math. I've recorded math for 2 years now. There's videos. They will be posted on Schoology for class discussions if you miss them. So you can actually watch the videos. But if you go to the evidence section of your textbook, evidence section, and then you go to about page 49. We get to the skeleton portion, the bone portion of the textbook. And it gives you a picture of the skeleton, Mr. Boney's sidekick. And then as you go through here, it'll list the bones and give you descriptions and stuff. Again, whenever we start using bones, whenever we use bones to identify, whenever you do stuff like that, use the book. Because you're going to need this at some point. But if you flip over here, this is page 54 and on. This is where you get into how you identify the bones as whatever. Take the bones, and these are bigger pictures, so they're not that. I've made pictures of them, but these are the bones straight out of the book. Got race and gender. But these are the pictures, and I can blow those up if we need. But you have pictures of the bones. These are the gender bones. You look at the male and female. The most common difference between male and female, of course, they mention the bone, but also the fact that on the back side of the male skull, you have a little bump, and the book calls it the occipital condyle. I published a video identifying the skull, and I had some guy who's a PhD guy chastise me. But that's not that. Well, I'm sorry. That's what the book says. I can only teach what the book says. But that's what the book calls the occipital condyle. It's a bump on the back of the head. And the first time I taught this class, 16, 17 years ago, one of the young ladies in class said, yeah, that's what we aim for when we hit the back of the head. But that's about where the back of the head joins the neck. And I'm not saying all males have that. Understand, science is all about averages. So there are some males out there who don't have the occipital condyle. There are some females that do have the occipital condyle. But statistically speaking, more males have it than don't. So when you're trying to identify male and female, make a list, male attribute, female attribute, and go down. And when you get to the bottom, the one that's got the most in them, that's the race or gender you're going with. So the male is, again, most of them have male occipital condyle. The bones are more boxy, more straight angles, not as soft. Mr. Boney here is not very good about this, but they actually have, a lot of the males have a brow ridge, a little bit of bone kind of sticks out a little bit above the eyes. If you look at Mr. Boney, you can see a little bit, not as good as some of the other skulls I have. But most females do not have a brow ridge. A lot of guys do have a brow ridge. There's a couple that I don't. So you can tell male and female. That's one of the harder things to tell, though, the male and female. But understand, you just do the best you can. If you flip over a couple more pages, they actually get into the races. And again, we already talked about the fact that we have 3 races. But you can get into races. Our textbook only talks about 3 races. But if you look at the eyes, all the orbits, you can look at the orbits and shape of the orbits, and that will tell you a lot about the race. Mongoloid, which is the first one, the upper left hand. If you look at the eye holes, they slope more than the other two races. Okay, now they both slope. They all slope a little bit, but the Mongoloid slopes more than the other two races. If you look at the nasal opening, the Mongoloid is almost circular. If you flip it upside down, it looks like a heart, but it's more circular than the other two. The Caucasoid is long and narrow. The Africoid is wider. So again, you got to look at the fine on these things. The biggest catch on the race is on the Mongoloid. You look at the jaw, they have a little arch, which is called the sagittal arch. Sagittal contour, it's arched. Mongoloids have that. Now remember, Mongoloids fall into the case of Asiatics, Pacific Islanders, and Native Americans. So there's a lot of population that has that, so it doesn't narrow it down much, but it is one of the keys. You can minimize it a little bit. Another thing, and I've done this before. That's why I printed those up several years ago. If you take a straight edge and you lay it, you're just going to lose the top of your head. This skull is old, so it doesn't want to stay very. If you take the straight edge and you lay it on the face, you'll notice you touch the teeth and the top of the nose. Well, if you do that on the skulls in the picture here, the Caucasoid, the nasal sill at the bottom of the nose, it actually sticks out farther. And if you put the straight edge on here, it'll actually touch. And you won't touch the teeth unless the guy's got really bad teeth. Okay. The Africoid, there is no nasal sill. So you can look at that and say no nasal sill. That's one drawback, one thing. But you can look at that and just put the straight edge. That's one of the ways to tell the race by where does it fall, what does it do. But again, you got to look at the overall picture and just go through it. And if you go back one page, this big old long list, this will actually tell you what to look for using scientific words. And I mean, it's probably, if you use it all, it's good. But this is the whole point of this is you're going to be using this Monday, and I'm going to give you the book and your partner to identify. But we are going to do something else right now. You guys are going to get to help each other. We are going to do, if you find your body in a hole back there and the bugs have all eaten all the way skin and bone, and there's nothing left but bones. By the way, the bones are the last thing that are there. The teeth are the hardest bone in the body. And when we get to DNA, we'll talk about this. You can actually get DNA from the teeth. So you can find DNA from your body thousands of years after you've been dead. But what you're going to do is we are going to get you to measure one of your bones. You got 3 on this side, 3 on this side, 3 on this side, 3 on this side. You get to pick a bone. Okay? And then I've got the tape measure over here. You're going to measure the bone. Now, you're going to need help. For the mere fact you can't hold both ends of the tape measure. Now, if you're using your leg, you might be able to.
As I said, you underestimated power. Figure it.
Well, no, because you got to end at the bone. You can't overshoot. Okay, so you got to hold it at the bone where it starts. If you measure the humerus does not start at the top of the shoulder. There's a little dip. You feel it around, move it around. There's actually a little dip right below the top of the shoulder, which is here. The bone actually starts about an inch below the top of the shoulder. And then you're going to bend your elbow, and it goes to the end of the bend. So if you're going to measure the humerus, you got to go right below the top of the elbow, right below the top of the shoulder, and measure from there to the end of the shoulder. And depending on which bone you measure. If you're doing the forearm, remember it's to the knuckle, to the joint right here, and to the joint right here, to the knuckle. If you're measuring the femur, you can measure that by yourself. But if you get a partner, you're the one that holds the top part of the tape measure. Your partner is not holding the top part of the tape measure. They can hold the bottom down near your knee. You'll understand why. The fibula, though, is kind of hard to get. It's kind of hard to find. I mean, you could do it if you could find it, but the tibia is the best. Tibia or femur are the best on your lower part. Any one's on the one at the top. But if you flip your book to page 50, 59. There are some formulas here. And math is wonderful, is it not?
No.
There's some formulas, and I have calculators, I teach math too. That what you do is you're gonna measure the bone length. You're gonna convert it to centimeters, because science is all about the metric. There's only 2 countries in the world, possibly 3 countries in the world that still use the English system. The United States and two countries that are smaller than the state of Oklahoma. They use the English system. One of them is Liberia, and the other one is what used to be called Burma, that's now called Myanmar. Those 3 countries, the only one that still uses inches and feet and stuff. So everybody else, scientists, things like that, they all use metric. So I have some tape measures over here. What you're gonna do is, and I'm making these numbers up, so don't. I'm gonna measure my bone. So I'm gonna measure my humerus. I'm making it up, so don't think I'm doing this. And I'm gonna say it's 18 inches long. I'm gonna take that 18 inches and I'm gonna multiply it times 2.54, because that's how you convert from inches to centimeters. And it gives me 4572 centimeters. I'm then gonna look in the textbook for the formula. Ladies, I'm sorry, you only get 2 races to choose from. So if you're Mongoloid, Native American, Pacific Islander, or anybody like that, for today, you get to be an honorary white person or an honorary African, okay? Just the way it is. I didn't create this book. But I am a Caucasoid. I use the humerus. So what I'm gonna do is I'm gonna write down the formula. If you've ever had in this ordnance class, you've heard the term slope intercept form in algebra? It's an algebra formula, slope intercept form. Okay, mx plus b. So what you're gonna do is you're gonna take your centimeters and plug it into h, and you're gonna multiply it out. And I got, and again, I'm making these numbers up, I got 211 centimeters. Now just go that. And then to figure out how tall I am in American, I divide that by 2.54. That's tall. And I get 83 inches. Will Chamberlain, eat your heart out. Okay? And what you're going to do is, after you figure out mathematically, we all check the math to make sure it's good, we're going to take another tape measure. We're actually going to measure how tall you really are. And we're going to compare. Mathematically, how tall are you versus how tall you really are. Now, question. Let's say, this actually happened. We had a student who did the math, and mathematically, she came out that she should have been 5'9" tall. We measured her. She was like 4'11" tall, like 12 inches difference, 9-10 inches difference. Is that a good number? It's a question.
Theoretically, no.
Actually, she had a genetic disorder. Her arms are actually shorter than they should have been because of a genetic disposition. Also, and I'm not saying anything bad about that, she was not racially pure. One parent was Native American, Mongoloid, and the other parent was Caucasoid. So the races were a little bit different. Also, she was still growing. Guys, till you're about 25 years of age, you're going to continue to grow. Everybody, bit of you, your brain and everything. So she was still growing, plus she genetic disorder, plus she wasn't ethnically pure. Hitler would be freaking out about this time. But the thing is, whenever they give an all points bulletin in the police, they never say exactly 5'3" tall. They give a range. It's a ballpark. So things can be off by quite a bit. And I stood and watched her measure everything. We did it all together as a class. And yeah, the math came out and it was a legitimate number. So the point of it is if what you calculate is way off from what you actually measure, do not flip out. As long as you do the math right and we measure everything right, there's no wrong answer. Okay. So what we're going to do, again, you can pair up if you want to. Sometimes you have to. This is the form we're going to do. So, again, I don't care. This is not, but if you are of mixed race, you got to pick one of the three because that's the only formulas we got. So just pick one. Ladies, you cannot pick Mongoloid. So if you are Native American, sorry, you got to pick one of the other two.
I don't understand that.
Why?
Why can't, like, what's the whole thing about that?
Because the book did not have it in there and we can only go by what's in the book.
Okay.
And I have looked up the formulas. I can't find these formulas. Most of them, they don't have the formulas. They just give you the charts, which I recreated a couple charts on the back. They just use the charts. So if you are Africoid male, you can use one of these charts. Okay. Gender. I'm taking you at your word. I'm trying to be sarcastic. We did this activity about 6 or 7 years ago, and there was a student in this class, did everything but wear dresses at school every day. I mean, and filled out the form and listed male. I said, dude, you got to put what you are biologically. He said, I'm a male. But he dressed like a girl, he bra, the whole works. I mean, nobody knew he was a guy. I mean, I was the first one to know he's a guy because he confessed, I'm a guy. Well, he graduated, he came back later, he had a wife and kids. So he was a guy. He just, while he was in school, he dressed like a girl. So if you go that way, I don't care. But for this, you need to put what your real gender is, okay? And you only got 2. And then pick one of the bones, doesn't matter which. There's 6 bones, pick one of them. And then what you're going to do is you're going to start filling in the chart. It's basically the steps we just did. Take the formula straight off the book, fill it in, do the math. I have calculators. But as a group, we're going to do this, okay? So if you got any questions, let me know.